Databricks wants to weigh in?
Yeah, just to jump off of Jay's comments about complexity. So yeah, I think it's important to distinguish the goals of what you want to, of what the Lambda architecture is designed to fulfill, and the actual implementation of having two totally different systems for running your offline and online processing. I think the Lambda architecture was a great way to describe sort of one incarnation of being able to take data that's coming in a sort of real-time, low latency fashion, and data that's sitting in a very potentially slow batch system, and get a unified view of results. The actual implementation that was recommended to achieve that, I think, has some serious drawbacks. And one of it is trying to reconcile, maybe hundreds of metrics or different types of business logic in two totally separate systems. So that's something like with Spark Streaming we focused on a lot is the assumption is baked in that the batch processing system is really slow. So you need to use two different systems, and we hope that people don't have to choose that anymore. So I just think it's important to decouple the goals of wanting to do continuous processing from the specific implementation that's recommended by the Lambda architecture.
One thing I would point out, though, is when you look at the notion of having online processing versus offline processing, that certainly at Quantcast early on when we were doing this, we actually used a simpler approximation for online scoring to capture the high order bits, but we didn't want to spend the resources to do this full computation that we were doing offline, right? So in fact, it was a good choice to have different implementations so that we could be very lively and use more modest resources in the online version. And that's a force. Of course, all things equal, having a common stack and doing things as consistently as possible is good, but I think it still ends up being the case that at scale you probably want to have a simpler kind of model for your online processing.
I guess one thing that people tell me is sometimes the complexity of the Lambda architecture is actually worth it, right? So in any of your customers, for example, Jay, have you encountered people who insisted that this is the right path for them?
Honestly, if you take the stricter view of the Lambda architecture as described as having the same computations being performed on different datasets, streaming datasets and batch datasets, I don't actually see that very often. My loose definition that I borrowed from Eric is actually the version that actually is much more common, and it's really like, at that point, it's just normal machine learning
yeah,
systems.
that's just using
yeah.
It works.
Yeah, that works.
But Jay, are you saying it's like offline learning and online kind of prediction and scoring?
Like you compute some ingredients and then you use those ingredients elsewhere. Right?
That's the standard model.
But I think what we're talking about is you compute the ingredients here, and then you also compute the ingredients here, and you
those are different things.
Merge it together, which is different. Right?
And arguably even have two NoSQL databases, one that's read-only and one that's read-write, right? If you really follow the Nathan's original model, which is something nobody is implementing.
And that's not a pattern. I definitely don't see that pattern as a common thing. Actually, I don't see it at all, mostly. It's very rare.
So the original application seemed to be much more, actually you guys keep talking about machine learning, but some of the original applications seem to be more like OLAP, combining real-time and batch, right? So, but nowadays you seem to talk mostly about using the Lambda architecture for scoring models.
Actually, interestingly enough, for streaming use cases, one of the more standard streaming use cases, the two standard streaming use cases we see are basically data preparation, data cleansing, so it lands ready to be used, so a SQL database can immediately access it, or pre-aggregations, views basically. Those are the two most common applications we see for streaming, much more so than machine learning, which is obviously has a higher barrier to entry. So.
One thing I think is notable, right, is that in an artifact of Hadoop 1 was very high latency of running jobs. So the micro and micro batch was not that micro, right? The Yahoo homepage cycle of 5 minutes was pushing the envelope, right? But now with Yarn, you can reduce micro batch down, in MapReduce 1 to certainly a minute, and with Spark to seconds, right? So suddenly you don't have a need to have a whole separate execution engine to do aggregations of events in near real time. You can do micro batch, and for most kind of aggregation use cases, doing aggregations in milliseconds every few seconds is plenty good enough, right? In fact, we've built some IP around that at Think Big to automate that and make that a standard capability.
Yeah, no, I totally agree with that. I think the assumption baked in the Lambda architecture is that there's this big rift between what's achievable in low latency, second level latency, and what's achievable in much higher latency batch system. And that rift has closed in a way that changes the dynamics, I think.
I frequently hear the term actually that people are implementing the full Lambda, kind of like the full Monty. Right? Apparently there's a partial Lambda architecture. So are there like variations that are much simpler that people are latching onto? So I think Ron, you talk a lot about this too.
Yeah,
right?
yeah, absolutely, right. I mean, I think that there's a number of elements of Lambda architecture that are overkill, right? That for many use cases, right? So put aside, we already talked about in the panel about some of these things like, hey, guess what? Now there's lower latency ways of processing. Maybe you can collapse and have kind of an architecture where you can feed data in and do aggregations and some basic ETL in one place on top of Hadoop and Yarn and feed it into a system like an HBase, which makes it really easy to serve out live results, right? So suddenly maybe you don't need all the layers for a real-time queries, aggregation type use case. Does that solve all the problems? No, right? That doesn't address things like how do you do machine learning like we've talked about in some other use cases. But it's a simplification that can be valuable, right? And in other cases, in fact, many machine learning use cases, what we'd see is you have a fairly small amount of work to read and write state in real time. So you get an event in, you can read a NoSQL database with a small constant number of things like reading about the person who's interacting and the page they're interacting with, get some information, do a real-time update of state, and write something back out as you serve a result. So you can embarrassingly parallel shard out work across a bunch of web servers, app servers, and interact with a NoSQL database, and still have that integrated in with an offline computation in Hadoop, right? So those types of use cases, those types of patterns, we see as often simpler alternatives to what people have traditionally thought of as Lambda. So maybe another way of saying it is, a lot of times when people think about Lambda, what they're really thinking about is having a streaming CEP type system like Storm as part of the loop, right? And where does that really shine? Well, I think where you really want to have that is where you've got computations that are not scaling, that might scale and use a lot of resources. So you want to be able to distribute those computations over a number of workers, right? So there are some use cases where that comes about, but it's not that common in practice, right? There's a handful of people that really have a need to scale the processing across many machines in an elastic way, per request.
But I do think the one problem that was being solved in the Lambda architecture was how to reprocess your data when your algorithm changes or when your code changes or you change the definition of what results are. And so in that case where you described just having a stream processor that processes things as they come in, you do have this new problem, which is like, hey, maybe I fix a bug in my code and now my results would be different. How do I integrate that? Like, how does that come into play? And that is something you have to deal with if you're building a streaming application. And the Lambda architecture was one approach to kind of handling that, because they're saying, well, we'll always recalculate everything, in our other code, and we'll push that out. So that will hopefully, correct this over time. I don't know if that's the easiest way to solve that problem, but I do think it requires some thought, because when people think about streaming, they just think about, oh, I got an event, I'll process that event, I'm done. It may not be quite that simple if you ever need to go back and change how the code works and have that be reflected in the results that you're materializing out of that computation.
I mean, I think it's a good point that you do want to look at whatever you're deriving as a view that's computed from the raw history, right? So no matter what, storing the raw events gives you that ability to recompute your view, to change your algorithm, to recalculate things in a mindful way, right? So that's an important part of, kind of good practices, right? That one of the great things about big data is you can store raw data. Disk is cheap, you could actually store the raw data and as well as a derived view.
Yeah, so I guess, like Jay was saying, the two positive contributions are this notion of reprocessing and retaining your original data unchanged, right? What about some of the drawbacks? I think we've touched on some of them already. So Eric, anything you can add to that?
I think I'm just mostly restating what other people say, which is learning is keeping it simple, right? I've seen a lot of people get into a lot of complexity too early. So one thing that's really, Hadoop encourages is an iterative solution building approach. So if you think you need to build two pipelines, build one of them and see if it answers the problem. And I think a lot of people build two and then use one. If just in batch is often very nice and batch is getting faster. The thing I'd add is sometime if what you need is an approximate answer and you need it right now, just streaming is also perfectly good. And we see solutions like that too. But yeah, don't do the full-on architecture until you know why.
I mean, I think one thing you also have to separate is kind of the current state of stream processing systems from the potential state. And so, like, I guess I would often wear two hats in my job, right? One is guy who makes infrastructure, where your job is to say not like what do our systems currently do, but what like should they be able to do. And the other is guy who uses infrastructure, where your job is not to say like how could things be in the future, but like how can I use this pile of crap to make something that works. And if you think about that, I mean, I think there's nothing that says a streaming system needs to give approximate answers. There's nothing that says you can't compute all kinds of things, including medians. Like, you hear lots of deficiencies of these systems. A lot of these deficiencies are more just deficiencies of the thing the person has tried. I don't think that's the end state. I think it's very possible to do this kind of continual processing and have it span the full kind of computation that people want to do. One of the problems you have to be able to solve is reprocessing to make that practical. I see the Lambda architecture as a way to kind of get there with the tools we have at hand, which is like you got some batch stuff, we got some stream processing stuff that does some of the problem. If you kind of put these together in a creative way, you've got a solution to the problem, and that's actually pretty good. If you're trying to build something today and you actually have a requirement for low latency.
Yeah, I think one of the frequent criticisms is that Lambda architecture actually it means implement the same code twice in two different systems, right? But that's kind of a cheap shot at the problem. I mean, obviously you're gonna use systems like Spark Streaming or Hummingbird, but Jay has a alternative architecture that he labeled the Kappa Architecture. So maybe you can give us a quick overview of that.
Yeah, I mean, I think the name was originally meant as a joke, but...
But now there's a website.
Now there's a website.
I forget the URL, but you can Google it. There's a
somebody
website.
made it. I didn't make the website. So,
He made it.
yeah, I mean, the idea here is you do need to be able to reprocess results with a stream processing system. So a stream processing system, it handles data as it comes in, whether it's Spark Streaming and you're making little batches to process, or you're Storm or Samson, you process one message, it doesn't matter, you're basically processing data as it comes in, you're producing some result that probably somebody's looking at, and it's having some effect. If your code changes and you need that to, happen retroactively, like you're computing, counts of everything that happened, and your logic for computing that count changes, and you want your counts to update with the new logic, you're gonna have to go back and recompute it, and that was, I think, one of the critical things the Lambda architecture solves. The other way to do it is just to rewind the stream processing system back in time and reprocess. And it's almost too simple to deserve a name, but you can do that in parallel, right? Like, you have Yarn or Mesos or these things that will run processes. So you can run, your current up-to-date processor, which is processing stuff as it happens, and you can toss another one in there and have it go back to the beginning of time and recompute and make a new table which has results. That's the extent of that approach. The advantage is a couple-fold, right? Whatever thing you're computing with, you're using it in the same place. So you don't even need to span Spark Streaming to Spark not streaming. It's just whatever you computed with. The other advantage is you don't got to stitch together results in your serving system. I mean, one of the complicated things here is you've got real-time results coming in, and then you've got batch backfill updates coming in, and merging those two things in a sane way all the time is actually a very complicated thing to do. You can imagine all kinds of inconsistencies between the new code and the old code as you redeploy or as you make any change. And so in this model, what you would do is you would just reprocess, dump it into a new table. When that thing is caught up, you can flip over. You can flip over immediately to the new table, or you can flip over gradually with some A/B test or something, but every user can see a coherent experience, or every application or whatever you're using it for can see a coherent experience. So that kind of accomplishes a similar goal, but with a slightly different approach.
So Jay, if you have like a bug that happened and you have a year of calculation and you want to redo 2 days worth of that processing, in that model where you redo streams, you have to stream a year and 2 days to recalculate?
Yeah, but I mean, I think what people are saying in the Lambda architecture is you're just batch computing the shit out of all that all the time anyway, right? So I think
in practice it'd probably be based on doing like a partition at a time, right? And so if you have partitions, you just do a small delta to fix 2 days, right? That's the way we always would implement it. It's not, So streaming all of history is a massive increase in resources versus fixing a bug on the last 2 days.
Yeah, I mean, it depends on how you implement it, but then if you're implementing incremental computation in your batch processing, as well as probably batch computation in your batch, plus your streaming computation, now you got 3, that's going to be also.
I think in practice, everyone does incremental batch, right? That they take in a partition. No, I don't know anyone that computes all history. They take, hey, here's my last time slice, and I process my view for that slice, so I have a one-to-one mapping from partition to partition.
Yeah, no, totally. But then you're again, materializing, some subset in batches. So you do have to be able to expand that and go back and redo everything.
Right. So there's still a bunch of workflow around reprocessing. I mean, restating history, if it's deep history, is a big project.
Mm-hmm. But again, I think there's no law that says you have to reprocess everything. Like as in the stream, as in the example I gave, you can start at a particular point in time and just reprocess that if you feel like those results will integrate and you'll get the same answer as you would have, right? In other words, the change you made only affects that. If you can somehow make that
so
reasoning.
If you had a checkpoint,
yeah, I think it's
checkpoint.
exactly. I mean, we're basically saying the same thing. Like you have some history of what happened. Whatever your results are calculated off that history. The question is, what system are you using to process the original data into the view, and how does that output get combined with the regular stuff? I think those are like the 2 questions.
So when I first actually read Jay Krebs's description of the Kappa architecture, it seemed very reasonable. It seemed like a natural way to do things, but I haven't heard a lot of people rushing towards this.
I don't know. I think overall I'm very interested in stream processing stuff. I'm less interested in marketing the architectures. Yeah. I think either way, I think this area is pretty cool. I think as the technology is getting better, it's becoming a lot more practical. I think there's no inherent reason that this kind of continuous processing has to be kind of this very complicated, hard thing you have to do. And so I think that's what I'm excited about in the area. I am super happy to see people doing Lambda architectures. I'm not down on the idea. I think it just isn't necessarily the only approach.
No, but just generally, I think the notion that you raised earlier is don't think about the current state of stream processing engines now, right? So think about what you want out of your stream processing engine and try to get there.
Yeah, I mean, at least for people who are making the stuff.
Yeah. So Jay from Cloudera, I mean, is this something that you guys are paying attention to, these new types of stream processing engines and computations?
Absolutely, yeah. I mean, I will say that in terms of customer adoption, and Jay will make fun of me for only caring about customers, but in terms of customer adoption right now, it's been a big uptake. People are starting to do more, I wouldn't say complex stuff, but at least like making sure data lands very quickly in these environments. And then we do get, where before it was never the case that people were looking at like very low latency response times for complex processing. Mainly probably because it was like Hadoop is not considered to be a good place to do that. There were specialized systems which have done that in the past. There's a lot more interest in seeing if Hadoop can achieve those kinds of super low latency type computations at a high scale. I wouldn't say that we're quite there yet, but there are lots of interesting work going on in the Valley which is trying to attack this problem on Hadoop systems. So we keep a very close eye on what's going on from a technology perspective to see if there's any interesting solutions that we can actually advocate to our customers. I wouldn't say, yeah, as I said, I wouldn't say that we have picked on one such thing. Obviously, for a certain class of problems, we made a pretty big investment in Spark Streaming. That's something we plan to stick with. We're very happy with that as well for a class of problems, but I don't think it's the end-all for all of these kinds of problems as well.
So as you notice, I've left the Lambda architecture behind. We're now going to talk about we love the Lambda architecture, but we also love stream processing. So Patrick, you guys are behind Spark Streaming, but obviously you pay attention to the other stream processing engines as well, right? So I know you've been looking at Millwheel from Google.
Yeah, let me, I can't help but chime on something he just said, and then I will answer that question. So I think one other reason why, I agree it's still early days for stream processing, which many people here have said. One reason why it's picking up now more and more is companies actually have the necessary pipeline to get data to a stream processing system quickly. If you don't have all of the infrastructure to actually get data from wherever it's generated, message buses, things like Kafka, which didn't exist in kind of open source wide availability, really, only at specialized systems at Yahoo. If you don't have that broadly adopted infrastructure, then there's not much to process. So I think that's been a big shift, is that more and more people are adopting this types of software.
Yeah, I would
and
totally
allowing
second
them
that. Like,
to-
if your data arrives in batch, there's no way to process it
Yeah.
except in batch. Like, there's just no point in streaming the batch. Like,
I think that was why some of the early stream processing startups failed. Right?
yeah, that's
It's
at least my belief.
because you had no real-time data.
Yeah, no,
Yeah, I'm a company that's, I just started a company that's very interested in streaming data, so I think it's gonna be a big deal. But yeah, I mean, our belief is that, our belief in our experience was, yeah, as you start to get a lot of data flowing in real time, it's like supernatural to wanna process that in real time. And if you look at what infrastructure supports that domain of the company, today, it's kind of weak, right? Like, you've got a ton of people making databases. You have like a whole awesome infrastructure in the warehouse, from Teradata, which is a phenomenal piece of infrastructure, to Hadoop, which is kind of new generation thing. There's a bunch of people there, but like in the middle, you got kind of these old school enterprise message buses and not a ton. So I think it's a huge opportunity for the stream processing engines, Kafka, all that stuff, to really kind of modernize that area of the enterprise. And a bunch of stuff does happen there that's not part of the normal Hadoop world. Like, they probably wouldn't show up on your door talking about it, right? They're out there using the MQ series or whatever.
Absolutely.
But in terms of for companies making decisions, how important is latency though? How real time? How low latency do these applications have to be? So Eric, I don't know if you have.
A couple of thoughts. I mean,
Because many of these applications turn out to have a human being somewhere in the loop, right?
I would absolutely agree with that. I mean, how real time is a really interesting discussion, right? Because, yeah, I mean, how often if you can't repaint the dashboard but a few times, every few seconds, and an operator can't move the levers to react to the information, but every few minutes, then, maybe you don't need more than 15 seconds of latency, right? Less than that is perhaps not worth engineering. So that's a real point. But I think the other thing, just to echo what a number of the other panelists just said, is, I mean, there's a new world out there where people are getting a lot more streaming data coming at them. It's no longer, just the ad exchanges and the telcos that have this problem. All of a sudden, anybody who builds an app on the internet, it instruments that, now has a stream of data coming back in real time, and that is now processable in real time. So there's a lot more opportunity to do this than there ever was. And I think that's really exciting, and I think that's driving the evolutions of these frameworks very quickly, so that they can do more and are becoming more viable options.
And I think, also, just to jump on that point, I mean, I think 15 seconds is pretty real time. Like, if you take like the analytics domain, there's a lot of companies that somebody gets up in the morning, looks at the report, and realizes the business was pretty screwed up yesterday. Like, all of yesterday. And the hope is, well, we can fix it before this report comes tomorrow, and we find out we lost another day. And so, like, if you're in a web company, they've instrumented this stuff, and you find out about things pretty quickly, and 15 seconds would be awesome. 5 minutes is probably still pretty good. If it was like a day later and you found out, like, hey, we lost a lot of money yesterday, that is in fact a big deal. And so I think most of these type of analytical use cases, there's really two kinds. There's deep decision making, ad hoc analysis. That's always going to be, the domain of the warehouse. But anything that is kind of is our business functioning now type of a dashboard, that you usually want to alert off of pretty quickly, and you want to know that things are broken pretty quickly. And any complicated business has that same problem in the same way that tech companies do now. And you can look at the stack at Netflix or LinkedIn or any of these companies. They built awesome monitoring systems that do essentially kind of real-time reporting off of data streams.
I think a countervailing force there actually is, in addition to human latency, statistical significance is another constraint on how quickly you want to process things, right? So your mileage may vary, right? If you don't have Facebook, LinkedIn scale data, if you've got an interesting medium data problem where you want to use some of these new tools for the flexibility, you may find that there's really not a lot of insight from 1 second to the next, that you need to accumulate a little bit of data to get anything meaningful.
So I'm going to just go back to the current set of stream processing engines, because a lot of the people in the audience here are probably users of these tools. So in particular, I'd like to just drill down a little bit on the Apache stream processing engine. So I'm talking about Spark Streaming, Storm, and Samsung.
Are we ditching Millwheel?
We'll talk about it later.
Why don't we do those and then we can circle back?
Yeah. Cloudera probably kicked the tires on all three of these, right?
We did.
So-
We actually looked pretty closely at all of them before we made our investment choices in terms of what technology we chose. All three of them have their own sort of niches in which they're unique. The way we looked at it was that Storm specifically had a lot of complexity. It's a very powerful system. It gives you a lot of control in terms of what you can do, but it does require you to build much more complex topologies than you may want to, or maybe maintainable. I think the biggest challenge we found was honestly doing fairly simple stream computations would require complex topologies that with a lot of hand tuning, and that was not something that was long-term maintainable. We have customers who've been doing it for 3 years. We're like, pretty done with this because it's just too hard to maintain. So that was a big challenge, and also the fact that it required a separate area of knowledge outside of everything else you're doing in Hadoop. Obviously, that's one of the big strengths of the stuff that Spark has done. Was a big factor in our choice around Spark Streaming. We really think that's worked out well for us. A lot of our customers are quite happy with their implementations of Spark Streaming. For us, Storm was not a tenable long-term solution. It's great for what it can do, and especially if you have a certain type of problem where you have extremely low latency requirements and you have the willingness to invest engineering resources to develop that. That's definitely an option. I have to say we didn't look too closely at the stuff that Jay and team had done, so I'm not going to talk too much about that. But obviously, from an adoption perspective, it is not nearly the same place as either of these systems as well. So that affected our choices.
I'd like to get Ron's take on this because he goes out there to enterprises and probably helps them make decisions.
Yeah, absolutely. Well, so I think we work with a range of customers, and we've helped some implement Storm. We've had at least one of our customers using Spark Streaming. These are new technologies, and where there's a need, where it's the right fit, our job is to help customers make the right choice for how to solve their problems. So, it's not a one-size-fits-all, right? There's a variety of options out there. We want to do the right thing for customers, and as the market matures, right, we're going to help customers make the right choice. So we don't have to be religiously committed to one, right? We can help customers with what's the best choice for them, which is really important at this stage, right? I mean, one of the great things is all of these are open source. They have open communities, and so I think it's my feeling is we're seeing a faster consolidation and standardization in an open source world than in a commercial world. It's easier, for example, if everyone can see, well, Spark Streaming is mature and working well for open source distribution vendors to say, you know what, we're going to include that too because everybody wants it, right? So it's a little easier than if it's commercial technology that is, bitter competitors or one or the other controls it. But the net is, I think it's still early days, and that the thing that's going to really drive the success, I think, of any one of these streaming platforms is building that viable community, right? So, Jay, when you talked about some of the immaturity of Storm, it's like, will the Storm community respond and make it simpler and easier to run Storm, right? That's the challenge and opportunity, right? I think integrating Storm on Yarn is a big step forward that, one can actually run Storm on the same cluster management system that one runs Hadoop, right? So that's a step forward, just like I think that's been a big step forward for Spark. So I think we've had experience working with each, and Samza is interesting. We've never really had a customer that wanted to use it, and I think again it gets to that point of, is there a viable community? Is there enough traction around this? I mean, I think we were, even in the case of scalable queues with Kafka, we advocated it to customers, but before there was commercial support available, it was always a lot of concern by enterprises in terms of how can we support this stuff, right? We can't hire 10 great engineers like LinkedIn has done and some of the early adopters. How do we make this stuff work?
So I'd like to actually leave a lot of time for Q&A, but I do want to close by looking to the future of these stream processing technologies. So Patrick, we thought kind of hinted earlier, I wanted to talk to you about Millwheel. So this is a technology from Google.
So is Millwheel the future by implication?
I don't know, but everyone looks to Google. Everyone looks to Google for the future.
So I can say a few words. So I'm not an expert on Millwheel, and Jay may know more, to be honest. But there's a great talk that was very recently posted online about Millwheel. It's Google's internal stream processing system, and they've had it for many years. I think more than 5 years. It has an API that's sort of a record-oriented API, more similar to sort of a Storm. And they also have a higher level API that looks a lot like Spark Streaming that I think is much newer. Some things that Millwheel does that are cool is they have nice ways of dealing with the very difficult problem in streaming systems of if I want to define some windowing or batches based on time, what happens if an older event comes that's sort of behind the rest of the stream? How do I sort of deal with that? Do I wait forever to see, if I'm gonna, like you can't wait forever to sort of infinitely block, but you do want to kind of define a slack or a, I forget the terminology they use for waiting for old events. So it has, it deals with some of the hard problems in a way that I don't think the open source systems, any of them have really caught up with. But I'd encourage people to check it out, the talk that's been posted online. And Jay, do you have anything to add?
Actually, I want to ask Jay something in particular, which is something that bothers me about stream processing discussions in general is that everything is about processing, not much about analytics. And I think you and I have talked a lot about this. And you've always had the opinion that that shouldn't be the case, right? So.
Yeah, I mean, my take on this area is I'm pro all the stream processing systems. I think it will probably end up getting more diverse. I think there's a couple different uses for stream processing. One is basically an application development framework for asynchronous processing. Like if you look at what happens in a company, a lot of it happens asynchronously. Most of it doesn't happen in a stream processing system.
But no one talks about analytics. Everything is about processing.
Yeah, I think they will. I think that's the other area that's going to come. If you look at what is required to build like an analytical system inside Storm, it's a lot of work. And so for certain types of analysis may not really be worth it. The kind of analytics that is going to be useful is monitoring, right? So you're not going to do deep decision making in real time. You're going to do either monitoring, which can be a very sophisticated thing when done right, or kind of fast response prediction where you have some learning model. You can look at tech companies; they have things in all these buckets where they do it. I think the real deal is about bringing down the level of complexity to the point where it's easy for people to do. But yeah, my prediction is we'll probably see a processing framework in each major programming language, because it turns out, although everybody wants to use JVM frameworks that begin with the letter S that are in Apache, there are other people out there. There'll probably be stuff for them. I think we'll see higher level languages that allow you to process streams. I think it's going to be a really interesting.
We'll see DSLs.
Yeah, that's right. That's right. I think we already are. Right?
Yeah. So I think at this point we'll open up the floor for your questions. So if you can come to the mic, and what we want are questions, short questions in particular. So we don't want information. So if you want information that you want to communicate to the panelists, you can talk to them after.
Well, it's been a great panel, thanks. So Pebble just came out with a watch here a few days ago. They sold a few million. And they call it Time. And they don't have any apps. You just spin the time back and forward, and you see where you were at that point, calendar, whatever. An OS X with Time Machine, people get a lot of experience going backwards and forwards in their data. In this context, there's been a lot of talk about retaining all the raw data and potentially having to reprocess it from day zero. In the business context, the business has a state day to day that's actually quite complex. And once that day has gone by, that was its state, whether there was a computational error and they served bad ads to people, if they're Google, or they made some financial mistakes if they were a stock trading company. Okay, right, I'll get to the point. So the question is, how do you help people when they have state in these systems that is a derived state that they want to maintain. It isn't the raw data. It's the actual activity. You know, it's their actual state at a particular point in time that they got to, using whatever tools they had at that point in time. And that becomes something that they need to retain. How do they retain that? How is that you know, event system leading to the retention of the actual time series state of the business?
You know, I think one of the patterns that's really powerful around that, I mean, first of all, that's not a new problem, right? That's an old problem in data warehousing, where you can't change history. You want to be able to know what was the state of understanding at the time, and not reprocess and fix errors that restate results that you relied on, right? But one of the things I think is powerful in a big data system where it's more feasible to normalize is you can and should, in your real-time processing layer, record the salient data that was used to make a decision, right? So, you know, if you have model state you've recorded, record that right along with the event, so you know exactly the state that was used to make that decision, instead of the doubtful proposition of saying, let's see if we can reconstruct the algorithm that was used at the time to compute the result that was used to make that decision.
Yeah. Thanks.
So as the moderator pointed out, probably these are early days for using, you know, Lambda/streaming architectures. For most business apps like, you know, fraud, credit collections, etc. Fraud may be the only one that you need, streaming architectures. The rest you can use your traditional architectures. So is it fair to say that maybe Lambda architectures, the best applications are in security?
I wouldn't say that. There's actually most things that require that kind of speed are typically full cycle systems which automatically respond to changes. Like, I can give you an example in healthcare where customers of ours are doing hospital change, just doing sensor data being sent to a system which actually does a processing and makes recommendations to nurses on how to react to patient activity. So anomalies usually is what you're looking for to some extent. I wouldn't even say that's a strict rule. Security happens to be one where you look for anomalies, but there are other areas where you're looking for anomalies as well, and that's often done in real time. But usually the characteristic that I care about is full cycle, where you're not waiting for humans to respond to stuff.
Yeah, I would